हेलो स्टूडेंट्स, वेलकम टू प्रवेगा एजुकेशन। आज हम लोग एक बहुत इंटरेस्टिंग वीडियो लॉन्च करने जा रहे हैं विच विल जस्ट टेल यू अबाउट द फाइन स्ट्रक्चर कांस्टेंट। Although it is just a number, but there is a story behind that. So we will just talk about the story behind this particular fine structure constant. And we will also talk about why it is so relevant in our modern physics. But before going to, let's go to the very brief journey of physics. And these all journey can be conceptualized by some constant. For example, when we are talking about the Newtonian world, so when we are talking about mechanics, the celestial body, and we are just talking about Newtonian world, then the very famous constant is all about the gravitational constant. So this is our gravitational constant, and the gravitational constant, the value of this is 6.6 into 10 to the power minus 11 Newton meter square and kg to the power minus 2. So this is your gravitation constant. And once we have gravitation constant, we can find the value of g, and we can easily apply the Newton's law and all these things, which will be mainly work for the macroscopic particle such as sun and earth system and something like this. The another very interesting constant is basically the Boltzmann constant, which will actually deal for the thermodynamical property, and that Boltzmann constant have value k, and this k is 1.38 into 10 to the power minus 23 joule Kelvin inverse. Now the another field of physics. So here we have the separately we are just talking about the celestial body, and here we are talking about the gaseous particle, the thermodynamical behavior of the particle. Here we are just talking about the mechanical behavior of a particle, such as that which type of force, and this force can be easily governed by the Newton's law of motion. And here the Boltzmann constant is a very fundamental constant which will just tell you all about the thermal behavior, for example, internal energy, for example, entropy, that can all be leaded by this particular constant. Now, the next very important constant is all about from the electromagnetic theory. So if we are talking about the electromagnetic theory, it has mainly not only one constant, rather more than one constant. So first is our relative permittivity, that is epsilon naught, and the value of this is 8.85 into 10 to the power minus 12 Coulomb square Newton inverse meter minus 2. So something like this is your epsilon naught, but this is more famous, 1 upon 4 pi epsilon naught, and that value is equal to something 9 into 10 to the power 9 Newton meter square Coulomb minus 2. And the another constant which is easily used into the basically electromagnetic theory for the magnetism, that is the permittivity for a free space, for a magnetic permittivity for the free space, and this is electric permittivity, and this is also for the free space. So this value is equal to mu naught. And what is this value of mu naught? This value can be written 4 pi into 10 to the power minus 7 Tesla meter ampere inverse. So this is our mu naught. And first time we just try to go for the unification. And here we are just working for the a Newtonian world, Newton's or mechanics we are using. Here we are using for the thermodynamical world, and this is for the EMT. And once electromagnetic world will come into picture, we have first time introduce a theory of unification. And what we try, we just try to unified epsilon naught and mu naught, and that will give us the awesome constant, that is c, that is what? Speed of light. And we all know that C is equal to 1 upon root under mu naught epsilon naught. And this value is equal to 3 into 10 to the power 8 meter per second square. And then once we are getting this particular value, and this is the speed of light in a free space, and once we are getting this particular value of C, which is constant in the value of C, that is speed of light is constant in a vacuum, and the value is 3 into 10 to the power 8 meter per second. And you can see this C is responsible to unification between electric field and magnetic field. And we have a wonderful theory of Maxwell's theory of electromagnetic theory. And now, once we have this particular unification, then it came to the all scientists' brain that we should develop a unified theory where all kind of forces can be unified. And then we have a modern physics, and in this particular modern physics, we have very famous constant. That constant is H, and this value is 6.6 into 10 to the power minus 34 joule second. So this is a dimension of angular momentum, and this H is known as Planck's constant. So now you can see, if we are talking about the separately we can talk about for a celestial body for the gravitational constant, and this is mainly for the mechanics, for the thermodynamics, another field of physics, and for the electromagnetic theory, this is another field of physics. And here we have developed a new theory, which is the C is just used as a constant, that is a special theory of relativity. This is all about the EMT. And here the H is the basic building, the basic concept for modern physics, for the quantum mechanics, where we are using the H. And this is for the quantum mechanics. And you know that quantum mechanics is used for mainly the microscopic particle, and where we have a wonderful theory of quantum mechanics, and that can be easily parameterized by this particular H. So this is very interesting. But people try to unify all the theory, and in this between, to understanding the hydrogen atom spectra, the fine structure of hydrogen atom spectra, what we have done, we have a new constant, and that new constant is nothing but fine structure constant. So let us see what is this fine structure constant, and then we will see that why it is so important. So students, when we are talking about fine structure constant, then this fine structure constant can be defined by the Greek letter alpha, and this is nothing but E square upon 4 pi epsilon naught h cut c. And where E is just a charge of an electron, and that value is equal to, the value of E is equal to 1.6 into 10 to the power minus 19 coulomb. So this is our fine structure constant. And now you can see the beauty of this, that you can see this fine structure constant have a function of epsilon naught, which is part of electromagnetic theory. It has a constant, is its function of H, which is actually the basic fundamental constant for quantum mechanics, and this C is just a constant for a special theory of relativity and the electromagnetic theory both. And the beautiful part is that when we are calculating this particular value, it obviously everything is constant, so it has to be come to the constant, and this value is equal to 1 upon 37. So this is very small value. But the beautiful thing is that this is dimensionless. So this is dimensionless. So students, you can see when we are working through the separately for all these particular fundamental constant, we have some dimension, But once we try to accumulate some of them, obviously the K is not a part of this, the G is also not a part of this. That is the real challenge, that how we can include all these constants together such that we can go to the grand unified theory and something like this. But here, this is the first approach where we have just tried to unify electromagnetic theory as well as your quantum mechanics as well as a special theory of relativity. And once we have, and this is very interesting, you are just every time you are aware of E square by 4 pi epsilon naught, and you are also aware of HC, and obviously H cut is the part of HC, that is H cut is nothing, but we all know H upon 2 pi, so we have H cut C. And now you can see, if we have this particular thing, that value is the constant, and the beautiful thing is that it is nothing but it is dimensionless. So if it is dimensionless, the benefit is that you can easily use this particular constant at the any place. You can write your all the energy, you can write your all different constant, all your fundamental variable in form of alpha. And that will make our life very easier. And so why this alpha, which is known as fine structure constant, is very important. And it is mainly used for the electromagnetic interaction between the fundamental particle, and it is used for the atomic physics to understand the hydrogen, the energy of hydrogen atom or hydrogen-like atom, and obviously for the quantum electrodynamics and all these things. So this is a very fundamental constant, alpha. So I will just suggest you that try to calculate all this number with yourself. And I am also giving you one basic homework, that this homework is all about write down energy of hydrogen atom as function of alpha and rest mass energy of electron. And you can say that rest mass energy is m naught c square. So students, try to calculate this particular thing. You will find that okay, it is very easy. If you have any doubt, and I will just suggest you that whatever the answer you are getting for this particular problem, just write in your comment box such that we can discuss, we can just extend this discussion to the next level. Okay, so students, just try to figure it out, what is the actual value of alpha, and it is very important that you should know at least these fundamental constants before starting your preparation. I have seen that lot of people are just going through the examination, but they don't know what are these constants and what are the use of these constants. Thank you.